All right, this is our last lesson of the year, so pay attention, take notes. We're looking at infinite geometric series today. Yesterday we looked at finite. They always had an end. You'd add up the first 6 terms, you'd add up the first 4 terms. Today we're looking at infinity. All right, so let's look at these 2 examples. If you need to, pause the video and write down these notes. Okay, so what I'm doing is I'm taking 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. The next one's going to be plus 1/64, and so on and so on and so on and so on. Partial sums means I'm going to add up the first term. Okay, well, I know what the first term is. It is 1/2. Then, that's how I got this number. Then I'm going to take the first 2 terms and add them together. So 1/2 plus 1/4 is 3/4. The sum of the first 3 terms is 1/2 plus 1/4 plus 1/8, and that gives me 7/8. The sum of the first 4, I add up the first 4 terms, and it should give me 15/16. And so on, so on, so on. Okay, so my first term, I'm just approximating these values, and what do you see? It's getting closer and closer. For my end behavior, it is getting closer and closer to what number? Well, the next one would be 31/32, 63/64. It's getting closer and closer and closer to 1. So it converges if the absolute value of your ratio is less than 1. So what did I multiply to get each of these? Well, my common ratio is 1/2. Is my absolute value of 1/2 less than 1? Then your answer is yes, you will get an answer. Now let's look at the second example. Again, n equals 1, I'm going to get 1/32. Then I add up the next 2, and I get 3/32. And then I add up the first 3 terms, and I got 7/32, and so on and so on. Well, when we graph that, we get like an exponential equation. So what is my R value on this one? My R value is 2, and it's going to keep going up and up and up and up and up and up forever and ever and ever, which means it diverges. That means it's never going to get to one single number. So if the absolute value of R is greater than 1, it's going to diverge, which means go to infinity. All right, so now let's look at these examples to see if they converge or diverge. So what we need to do, they told me it's geometric. I don't have to check for that, but I got to take my second value divided by the first. 1 divided by 2/3. That's going to give me 3/2. Or I could have taken the third divided by the first, which would have been easier. 3/2 divided by 1 is 3/2. The absolute value of 3/2 is greater than 1. So that means this one is going to diverge. Let's look at the next one. If I take the second divided by the first, I'm going to get 16/32, which is 1/2. The absolute value of 1/2 is less than 1, so that means it's going to converge. And you're going to see on our formula, these types of problems are the only ones that we can actually find a number for just like in that first example. The sum of all these will actually eventually get to be 1. So your answer would be 1 for the sum. It converges to 1. Okay, so let's do this one. It says, find and graph the partial sums for n equals 1, 2, 3, 4, and 5. Okay, so the sum of 1 is just my first value. The sum of 2 is going to be 1/5 plus 1/10. And that's going to turn out to be 3/10. The sum of the first 3 is going to be 1/5 plus 1/10 plus 1/20, which is going to turn out to be 7/20. The sum of the first 4 is going to be 1/5 plus 1/10 plus 1/20 plus 1/40, and that's going to give us 15 over 40. And the sum of the first 5, and actually what I can do is I can take the answer from the previous one and add 1/80th, which would be my next term, and I get 31/80. Okay, so now I'm going to write these down as approximations. So this one actually equals 0.2. This one is 0.3. This one is approximately 0.35. This one we have as 0.375. And this last one is 0.3875. Okay, so how are we going to get our points to graph this? So this point right here comes from 1 and then your answer. So 1.2. This point comes from the 2 and 0.3. This one comes from the 3, 0.35. This one comes from the 4, 0.375. And this one comes from the 5, 0.3875. Okay, so is this converging? Yes, it is. It's actually getting closer and closer and closer to this line right here, which is 0.4. So it converges to 0.4. All right, does everybody understand this partial sums? The sum of the first one, the sum of the first 2, the sum of the first 3, the sum of the first 4, and so on. All right, well, here comes our last formula of the year. Woohoo, write this down if you need to. Pause the video so you can write it down on your formula sheet. Okay, so this only occurs, you can only find the sum of an infinite geometric series if your ratio, the absolute value of your ratio, is less than 1. If it is not less than 1, then your sum does not exist, okay? It does not exist. This is also called a limit when we get to pre-calculus. So the sum is your first term all over 1 minus r. And here again is the summation notation. Notice the infinity sign at the top. Okay, you're going to need that. You got to see that infinity sign to know that you're going to use this formula. And this rule that's written out here, remember, always has a value that has an exponent, and that value is your r. All right, so let's do these. It says find the sum of each if it exists. So it tells us that these are geometric. So I always take your second value divided by the first. Here we go. So -5 divided by 25 gives us -1/5. Is the absolute value of -1/5 less than 1? Your answer is yes. So we can find the sum. So we're going to have the sum of infinite equals your first term over 1 minus r. So the sum of infinite equals, my first term is 25 over 1 minus -1/5. You put that in your calculator and you get 125 over 6, and you can just keep it like that. So it converges to that number. Okay, let's do it another way. Here's our summation notation. I look inside here. Whatever number has the exponent, that's my r. So is the absolute value of 2/5 less than 1? And your answer is yes. So we are going to find all of our numbers. How can I get my first term? Well, I can plug that 1 in. What's 1 minus 1? 0. Anything to the 0 power is 1 over 1 minus 2/5. And if you put that in your calculator, you're going to get the answer 5/3. Okay, last but not least, we take the second divided by the first. Is the absolute value of that less than 1? Your answer is no. So you're not going to have any sum. No sum is going to be your answer. Remember, the absolute value of your ratio always has to be less than 0. I mean, less than 1. Less than 1. So make sure you write down all the formulas and the aspects of the variables so you know what they are. Have them ready when you do the review tomorrow and take your quiz on Friday. Ask questions because this quiz is on Friday. All right. Problems that you're going to have to do is big ideas, 8.4. Good luck, and remember,